Chapter 9, Day 4 notes. We're still solving trig equations, but this time it says we're solving graphically up here. And the reason is, if you look at the equation in example 1, it says sine 2 theta equals negative 0.75. Looks pretty similar to yesterday. The only difference is this negative 0.75, that's not a number you see on your unit circle. All the ones we did in the day 2 notes were numbers we see on the unit circle, like root 3 over 2 or root 2 over 2. So since this number just isn't on the unit circle, we don't know how to solve it by hand, and that's why we're going to have to use a graphing calculator. So we'll pull those calculators out in a second, but first kind of let's set it up and talk about what we're going to do in our calculator. So we have two sides of our equation. We're going to graph both sides. So in y1 in our calculator, we're going to type in sine 2 theta. Our calculator, you can't really type in theta, so you could type in sine 2x. Really doesn't matter what the variable is, x, theta, t, r. It could be any letter. All right, and then in y2, we're going to graph the other side of the equation, that negative 0.75. All right, we also have to set our window. We only want the answers from 0 to 2 pi. If you don't set your window, you could see a ton of different answers, and we really only want the answers on 0 to 2 pi. So in our calculator, we definitely want to be careful to set the window. All right, and 0 to 2 pi, those are x values. So we're going to make our x min be at 0 and our x max be at 2 pi. That's the most important part of setting the window. You can also set the y values. Those don't matter as much, but you could think logically about, what kind of y values should we have? If we're graphing sine 2 theta, you guys know there's a 1 in front. Amplitude is 1. That graph goes up to 1 and down to negative 1. So we might want to make our y values a little bit above 1 and a little bit below 1, just so we can kind of see everything. So I'd make my y min negative 2. All right, and my y max positive 2. Just so we could see that whole graph, it's stretching from negative 1 to 1. We're going a little bit below and a little bit above that. All right, and then, negative 0.75, that's just a horizontal line at negative 0.75. That will definitely fall, in between this range of numbers, negative 2 to 2. So we're good on that. All right, so once we graph these, all we're going to do is we're going to find where they intersect. So we're going to press second trace intersect on our calculator. All right, and then we're going to press enter 3 times, and that will get us our intersection points. All right, so let's switch over to our graphing calculators and try to set this all up in our calculator and solve for the answers. All right, so let's try to graph both sides of the equation. If we go to y equals, all right, you could type in your sine 2 theta or sine 2x, and then the other side should go in y2, negative 0.75. Then we have to set our window. All right, we said the x's have to go from 0 to 2 pi. All right, we said the y's really don't matter. If I left my y's at negative 10 to 10, we can graph it. We can see intersection points. We just have kind of a lot of blank space on our graph. So if you want to zoom in a little, get rid of some of that white space, that's where I was saying, maybe negative 2 to 2 would be a better window. You can just kind of see a clearer picture of the graph. All right, it looks like we have 4 intersection points. To find them all, we're going to do second trace, go down to intersect. You press enter 3 times, 1, 2, 3. And you always get the intersection point you're closest to. So the x value is one of our answers. Let's round to 2 decimal places. We'll call that 2.72. All right, we still got to find the other intersection point, so do it again. Second trace intersect. This time, before you start pressing enter 3 times, you need to move your cursor so it's closer to the intersection point that you want. So I'm going to use my left arrow, just move closer to the other intersection point. It doesn't have to be perfectly on top of it, it just has to be close to it. And now if we press enter 3 times, 1, 2, 3, we get another answer of 1.99. All right, we still have to find the intersection points all the way on the right. So again, keep going. Second trace, intersect. All right, before we press enter 3 times, use your right arrow and get closer to the point of intersection that you want. Again, you don't have to be on top of it. You just have to be close to it. All right, if you press enter 3 times, 1, 2, 3, you get 5.14. All right, we have one more intersection point. Press second trace intersect. Again, use your cursor, move it over closest to the one you want. Press enter 3 times. We get 5.86. All right, so we could write those 4 answers down, and then we'll be done with the problem. Let's just write down our final answers for example 1. We got those 4 intersection points. All right, we're rounding to 2 decimal places. We got from left to right, we got 1.99. We got 2.72. We got 5.14. And then the last one was 5.86. All right, those are the answers we were looking for, and we're done. All right, so let's take a look at example 2. It says solve this equation on the interval. Same thing. We're going to graph both sides of the equation, set our window appropriately, and go from there. All right, so if we're graphing the left side of the equation in our calculator, we'll put that in y1. A little bit tricky because our calculators don't have a secant button. So we have to think about what's another way we could rewrite secant. Remember, secant is the same thing as 1 over cosine. So I would type that in as 1 over cosine. All right, plus sine is definitely okay. We can just type that in as sine. All right, and then in y2, we're going to type in negative 0.8. All right, again, we have to set our window. All right, from 0 to 2 pi. So again, our x min is going to be 0. Our x max, all right, is going to be 2 pi, which our calculator should already be, set that way. All right, and then, I'm not really sure for the y min and max. We might just have to play with that for now. All right, our y min and our y max. I don't know about you guys, but I don't exactly know, all right, what this graph, secant plus sine, is going to look like. All right. We're really familiar with sine and cosine graphs, but when you add those together, I'm not sure what that looks like, so we might just have to play with our window. All right. This right here, this is just a horizontal line at negative 0.8. So let's just graph it with our current window and, kind of see, do we need to adjust the y's? We might have to, we might not. All right, so let's take out our calculators and give this one a try. Graphing calculator, we type both sides of the equation in. Remember, we said secant is the same thing as 1 divided by cosine plus sine. All right, and then we got negative 0.8, set our window. Again, I have that 0 to 2 pi already. And, I'm not sure about these y min and maxes. We'll just leave it like that and kind of see, can we see everything? If not, we'll change it. All right, so it looks like the blue graph is our first graph. And that is our negative 0.8. Looks like we can kind of see everything to me. We're looking for the points of intersection. It looks like there's 2 of them. All right, so we're going to do second trace. Go down to intersect. You press enter 3 times. And let's round that number to 2 decimal places. Let's go at 2.91 is one of our answers. All right, we got to get the other intersection point on the left. So do it again, second trace intersect. But this time, before we start pressing enter 3 times, move the cursor over with your left arrow. When you're closer to that intersection point, that's when you can press enter 3 times. So 1, 2, 3. And we get our other intersection point, 2.26. So we can go ahead and write those answers down on our paper, and we're done. All right, so we were looking at example 2 here. We said the y min and max were totally fine from the last problem. All right, so those really didn't have to change. We are leaving them as negative 2 to 2. All right, again, sometimes you just kind of have to play around with those. All right, but we found where these graphs intersected, and we got our 2 answers, and they were 2.26. All right, and the other one was 2.91. All right, the tricky part is you never really know how many answers there's going to be, so that's why you have to set your window appropriately. So you can just kind of look and count and see, how many intersection points do you have? You could have 0 answers. There could be a no solution if your 2 graphs don't intersect at all. You could have 1 answer, 2 answers, 3, 4. Really, the options are endless, how many intersection points you could have. That's it for today's notes. Hope you guys understood this. Give the day 4 homework a try.